Before I go into the presentation of today, I would like to just give you an outline of the activities within the Center for Water Systems that I direct. So our main interests are in urban water, hydroinformatics, basically water and ICT. We work with quite closely with the industry and other research institutions, and we also offer postgraduate education. Just a set of mugshots of people involved in the Center for Water Systems. The main point is this is the largest group in the UK working on the urban water management side of things. So for today, I will just give a brief introduction to smart water systems and smart water system research at the University of Exeter. But I'd also like to talk a little bit about Europe-wide activities on ICT and water, and a little bit on results from a recently finished EU project that I led, which is called iWidget. And then talk briefly about the future for smart water systems and some conclusions. So you must have heard quite a lot about big data over the last few years. There is quite a lot of interest in the Internet of Things. We are collecting unbelievably amounts of data. For example, every day we create 2.5 exabyte of data, so much that 90% of the data in the world today has been collected in the last 2 years. So only 10% was collected before 2 years ago. And you know how fast computers we have these days. This is an example of a computer in the Defense Technical University in China. So we are interested, what can we do with that data? And that's what we are trying to do, in particular for water systems. So how can we manage data better? How can we explore data and understand our system better, and through analytics and visualization? So if we are talking about the ability to monitor, measure, sense, we can do that almost anywhere in the system. And that's what I think the project that we're talking about today is about. For example, in the world, there is 30 billion RFID tags, you know, those barcodes, and then 3.6 billion mobile phones able of taking high-quality photographs. In this year, we're expecting over 60 million of smart meters, smart utility meters, to be in place in Europe. So what are smart water networks? And I didn't want to come up with another definition of mine, so I borrowed one from Smart Water Network Group. So we're talking about efficiency. I mean, the president of the Portugal was talking about the need to improve the efficiency in our water supply systems. Longevity is another one, because the systems are aging, and I think I speak on behalf of every water operator in the world. There isn't enough money to replace all these pipe networks. Only in the UK we have 700,000 kilometers of water and sewer pipes. That's all the way to the moon and back. We have, in one country, 8 times more pipes in the ground than we have roads for our transport. So that gives you an idea how much or how important it is to invest. Measuring, collecting, analyzing, we're all interested in that. We're all interested in real-time monitoring, automation, reducing or increasing operational readiness, reducing losses, like in Lisbon. But the main thing is that it is an integrated set of tools, operational policies, systems, to look at our systems remotely. Again, if we're talking about this big system, how can we be everywhere all the time? Only by remotely sensing what is happening to the system and continuously to prioritize. Why do we need to prioritize? Because we can only affect or invest in a small part of the system and to optimize these water distribution systems or water supply systems. So why do we do that? What is, well, obviously there is more and more regulation. You know, we are producing something that people are consuming that is basic for the health of the nation. We need to optimize infrastructure renewal, again, because of the immense costs. We need to focus. Again, the talk before me talks about efficiency, so greenhouse gas emissions, energy optimization, operational efficiency is what every water company is looking for. Improved decision making. We have to have integrated decision making across company. How to guide strategy and investment and improve customer satisfaction and engagement. So what was acceptable 20 years ago is not acceptable anymore. Huge water losses, water quality problems, inefficiencies. Customers do not want that anymore. Just imagine, those of you of my age, 30, 40 years ago, what we put up with cars, you know, breaking down every few months, having to repair, and look at the cars nowadays. You know, they last 10, 20 years. The same thing happens to the water industry. Customer will accept less interruptions, less problems to the system, and that's what is driving most of this work. This is something again for the UK, but I'm quite sure that other countries are going to think about this. Like what happened with the electricity industry, where industry is now divided into generators and those that deliver or bill us for the energy. There is a move for the water industry to behave like that. So you would have suppliers, and then you will have ability for people to change a water supplier. Again, the need for customer satisfaction, to keep your customers, because nowadays water companies are monopolies. Who knows what will happen in 10 years' time? So the European Commission has invested quite a lot of money into investigative projects in terms of the ICT and water applications. And there is an organization, voluntary organization that I belong to, and we are the leaders in it, called ICT for Water, that combines all the EU-funded projects. And I suggest yours may be actually joining the group. These are just some of the projects or their logos. There are now currently 18. At the time when I created this slide, there were 15. So more and more are joining. This is just another slide that shows how widely collaborators are participating in these projects all around Europe. So what are the common threads of these 18 projects? What are these people interested? The main thing is water demand or consumption monitoring, because we don't have an idea of what the demand at the particular time of the day is, because we don't measure it. We maybe measure what we are putting in the system in real time, but not what is being consumed. So we're looking into what is being consumed, but what is happening in real time with the networks and households. Then we're looking into efficiency. Water loss management is still a big issue. And again, the Secretary of State for the Environment mentioned this morning that some networks lose 80% of the water they put into the system. Can you imagine a car manufacturer, say BMW or Mercedes, producing, say, 1,000 cars a day, and then 800 of those are scrapped, you know, thrown away on the same day? So That needs to change. Supply-demand management. Quite a lot of companies are struggling to supply water 24 hours a day, 7 days a week. That's even more difficult when we talk about future and climate change. Water and energy management, again, something that the president of ADP was talking about, very important. And, you know, can we do something about this system if we cannot forecast what the demand is going to be? And, you know, next 15 minutes, next day, next year, 30 years ahead, we still think, or the companies like theirs have to think about long-term sustainability. This is an interesting slide. This is the largest water company in the UK, Thames Water. And this is their water resources situation. This is the year 2010, 15, we're here, up to 2040. This is their water resources plan. This is megaliters per day demand. So this is the demand going up. This is what their supplies are looking like. So by 2020, they estimate there will be 133 megaliters per day, million liters per day short of water for the City of London, which is 9 million people. So they need to think not just about you know, being efficient, but also how do they meet this demand? One way is increasing resources. The other way is decreasing the demand. That's why this company has decided by 2030 they will have smart meters at each and every household in London. Another common thread from these European projects is about modifying customer behavior, reducing that demand, how to help them be more efficient, waste less. You know, through home display units, apps on your phones, web portals, through social media and gamification, or dynamic pricing even. You know, we've heard of dynamic pricing and tariffs in the electricity industry, but not in the water area. That's again something to think for the future. And what do we do in the control room? Can we use big data? Can we actually work both on the utility, the network side of things, and customer side of things? Because in the UK we estimate that 25% of the losses, so 1/4 of the losses, happen on the customer side, dripping pipes between the meter and the household. What are the common challenges? You know, sensors. They're not cheap. They're not small. They don't have their own energy supply when they're somewhere in the field. Data transmission is a problem, loss of transmission and so on. Standards, we don't have standards. Every company has their own standards for developing these sensors, for the communication and so on. And personal information about individuals. Companies like in Lisbon, they have access to millions of names, private information of people like yourself and myself. That has to be managed carefully. Then companies are very cautious about cloud computing these days, and that's where most of Internet of Things is moving. So will they or will not embrace this new technology? Open research data, the UK Environment Agency has released over 1,000 databases, complete water quality, sampling, everything that in real time. The gauges, rain gauges, all are now available for the public because the government funded. Why it wouldn't be open? But that makes another opportunity, another challenge to all of us. Integration of water and energy consumption data is an important one. In the household, again, UK figures, we use 30% of energy. So that electricity and gas most of us use, 30%, 1/3 is being used to heat water, not for heating space, just for showers, kitchen tap, and appliances. 30%. So you reduce water usage, you reduce energy usage. Water is cheap, energy is not. However, we have separation. You have separate energy companies, separate water companies. How can we get over that burden? So very briefly about the project that I mentioned to you. These are the partners, and you could see we had LENEC and AGS as partners in this one. We had a case study in the city of Barcelos in northern Portugal, 3 DMAs, about 400 households, data collected, measured every 15 minutes, smart meters at households, and collected every hour. We had Southern Water, about 2,000 customers in the UK. Interesting about this one was that the data was collected by automated meter reading by people in white vans going every day through a street to collect data for us. And something in Greece where we had water and energy meters. So the red ones represent both water and energy, the blue ones just water. What we did develop is a platform that takes all that big data from all these customers and develops information to show, to analyze, to help them. So we divided it into 2 parts, one for the utility, one for the customers. The utility wanted to know how better to operate their system, so they were interested in real-time water balance data. You know, where the water is going into the system, operating PRVs to reduce the energy in the system, or pressures to reduce leakage, or there was something on pump operation. Whereas on the customer side, the customers were, by the way, we consulted them before we developed everything. So we had several workshops with these people to find out what they're interested, what they would want the data to be used. You know, they wanted to get the forecast of their next water bill or water and energy bill. How can we, you know, compare energy pattern and water use in the same household? Can we reduce both of those bills? So just one example of both sides, one from the customer, one from the company. So, you know, water is not a very interesting subject to people who are not water engineers. So one of the big companies, Price Waterhouse, looked into how much people interact with utilities. And this is based on energy, let alone water, energy. In a year, people think about utilities 9 minutes. That's how much we think about water. So, you know, there is a problem there. How do we get them interested in water? Smart applications. Can we have, you know, you can have a bill that provides a very good comparison between you, your neighbors, and your efficient neighbors. So if you are using more water than everybody else, a competitor in you will start looking, hey, they cannot beat me. So, and also that information being sent to you in real time, say, you know, you're using more water, there must be something going on in your household. You know, if you're using water between 3 and 4 o'clock in the morning, well, obviously there are health issues if you're doing that, but something may be going on. You may be having a leaking toilet, you may be having a leaking tap, so those kind of things could be detected quite easily. But what companies are interested is, in the retail industry, they try to segment us. They try to divide us and tell us, you know, she's a big spender. he lives in a household with 5 people because they're buying so much toilet paper, or he's doing that. They want to know more about you so that they can offer better service to you. The same thing is happening with water companies. They want to know who is at risk of defaulting, not paying for water. Who is using too much water? You know, large family. Maybe there is a reason. But if they compare that, know that only one person lives in the house and there is a huge usage of water, there may be something going wrong with it. So you can see there is quite a lot of information we can get from that. From the utility point of view, we were looking, one of those widgets, one of those apps was looking into pipe leak and burst detection. So why? Because we want to look into where this system can provide us with most interesting information. Just imagine you're an operator in a control room. You have 2,000 district metering areas, 2,000 DMAs. You have to decide where the problem is, where to send the crew, or what is going on. And if you can have a system that will help you do that, and I will just skip A, and you say, okay, we measure everything, why can't that person find out? Well, this is one of the reasons. You know, the instrument is showing this is all real data from a real system. So instrument is showing, you know, pressure going up and down, and suddenly something goes, and then it's like that. Maybe the instrument failed, but that person will need to know it. Out of 2,000 signals. Or if something like this happens just for a short period of time, abnormal measurement. Or if the sensors start drifting, and you see they go and reset it, and then you get it again working as well. Or sensor is working in normal range and suddenly switches to this one, and after resetting it goes back to normal. So you can see that having the data, it's not all. We have to be sure that the data is correct. I will skip the background, but this is the measurement in a real system. We did testing on this particular system. This shows the flow into the DMA, normal diurnal pattern, you know, during the day. And we just do a blowout of this system. We have the average demand, predicted demand. We have lower and upper bound, and this is the actual measurement. So when the normal demand happens, we have green coloring of our real system. Demand is below normal, that's still okay. Demand just above normal, but shows amber, and then we go into red because there is some kind of anomaly. There is more demand than our system predicts. And then it gives alarm to our control person because, again, he or she cannot do that for 2,000 DMAs simultaneously. So if you look the day before, the day after, and our day when we had that burst, you can see that we have about 2 liters per second loss in the system that was detected by our widget. So just before I finish, I just wanted to provide one slide of the future and what we are thinking about smart water management in smart cities. And I borrowed this from Veolia. But basically, we want, first of all our services like energy, water, wastewater to monitor, analyze, control, and operate the system. But that's part of much larger smart city system where we have connected people, products, and services. So, for example, if you think water is only a health product, water can be used to actually look into health of our elderly people. So if you have parents who live in a different city and you have real-time data from your household, if they don't use water for a day or two, that should alarm us that something's going on in that household. Various ways we can combine the Internet of Things to help us better manage our lives. So I'll just finish with a few very brief conclusions. Efficiency is what we are after, and what I think the current project is after. Because of the aging infrastructure, we need to maintain it, at least with limited funding, under future uncertainties. Who knows what climate change is going to bring to us, and increased expectations. All of us are consumers, all of us are customers, we all expect more. Obviously, sensors are becoming ubiquitous everywhere, and they will become cheaper, and they will be installed more and more in our systems. So they bring opportunities, but they bring also challenges, as I've shown. Customers will need to be engaged more, and we are here to do that, to increase that efficiency in the household. And I would also plug in the role of hydroinformatics or ICT and water management to increase that level of understanding and identify technological, you know, the Internet of Things, mobile phones, sensors, and management opportunities, and to apply these new modeling tools that can support integrated decision making. Thank you very much. These are the people that have worked with me to produce some of these outputs that I've shown today, and I'm happy to answer any questions you may have. Thank you.